Bismillahirrahmanirrahim. Welcome back to my channel. I think 2 videos ago I made a video how I can use USRP as a signal generator. So where I have plugged in there's a code available on UHD which is known as UHD signal generator. Based on that you can generate frequencies out from your USRP, and then you can connect an antenna or you can power up your circuit. So you can use your USRP as a signal generator. So today I'm going to use my USRP, which is plugged in right here via BNC connector and SMA male, and that is connected to my oscilloscope right here, and we're going to visualize the signal which is being generated by my USRP N210. So for this I'm going to go to my GNU radio. This is connected to my computer, as you can clearly see right here. This is where my is connected to. So what I'm going to do now, I'm going to type in a post which is known as UHD signal generator underscore GUI, and I'm going to choose a frequency of about 100 megahertz because my oscilloscope is rated for 100 megahertz. That's the maximum signal I can see on my oscilloscope. So I'm going to type in 100 megahertz, and I'm going to run this script. As soon as I run this script, now this will run. As soon as I run this script, I will see a graph like this. So I see a control panel where you can generate a constant signal, complex sinusoid, Gaussian noise, uniform noise, two-tone signal, and sweep. You can select the frequencies from here. I'm just going to leave it at default at about 100 megahertz. At the same time, my USRP, the motherboard that I have, the RF daughter card that I have in my it is actually UBX. So UBX will be able to generate frequencies from 10 megahertz all the way up to 6 gigahertz. But I don't have no way of showing you anything above 100 megahertz because my oscilloscope is rated for 100 megahertz. Okay, so just to show you the basic principle of it, so I'm going to choose a complex sinusoid signal, and it is generating about 100 megahertz, and the amplitude, and this TXRX is actually the connection which is right here. You can connect your antenna, but I have connected via BNC connector to my oscilloscope, and this is what I'm seeing right now. So what I can do now, I'm going to go to my settings, I'm going to auto set this, and here we go. I'm seeing the frequency. I'm going to turn off the math option because it's also giving me the math option. So I'm going to do a default, and it's generating a frequency of about 100 megahertz from my USRP that is connected to my oscilloscope. So I'm just going to simply lower the amplitude down a little bit and play with my scale, and boom, here we go. I'm seeing a 100 megahertz signal. I can go to my I'll go to measure, and then from measure I'm going to add a measurement, and I'm going to add frequency measurement. I'll go to time and frequency, and I'll select frequency. Hence you will be seeing about 100 megahertz of signal. So this is what I'm seeing right now. So about 100 megahertz of signal. I can change this to Gaussian noise from my UHD signal, and this is how basically a noise is looking like, even though the signal lies at about 100 megahertz. This is about uniform noise, so this is being changed from here. So by changing it to uniform noise, this is what I'm seeing on my oscilloscope, a signal that looks something like this. Okay, then I can also change the amplitude. Alright, so as you can see, I can go to complex sinusoid, and then I can also increase the amplitude, so you can see the change in amplitude. So basically I am operating my USRP N210 as a function generator, so you can power up your circuits however you want. I can also play around with transmitter gain, which is a built-in power amplifier in your USRP, by changing this. So you can change this, and you can clearly see there's a jump in an amplitude when I change this transmitter gain. When I lower it down, when I increase it, I can see the change in amplitude as well when I increase the transmitter gain. So let me just reduce this down. I can also do a couple other things. I can go to a math function and then I can do FFT. When I click on FFT, I'll get FFT of this signal, channel source 1, yes, and by moving this, positioning this on top, and by lowering its amplitude down, and by calling my cursor in, I can move this and I can clearly see I have a signal that is at about 100 megahertz, right, and that has a signal strength of -9 dB. Okay, then I can do Gaussian noise, and let's see what happens to the spectrum at the bottom. Alright, so let's just change this to Gaussian noise, and I can clearly see wall. I can clearly see there's a lot of things in my noise floor, but there's not much change in the amplitude, so I'm not producing much of a noise. Basically you can still see a signal at about 100 megahertz. So this is basically a small tutorial. If you have SMA connector male handy, you can just connect it to your USRP like this right here, and then connect it to your oscilloscope just to see how does the signal look like. And you can control this using a program which is a built-in program which is known as UHD signal generator, and you can power up your circuits using USRP. So I hope you like this small tutorial. If you have any questions, leave it in the comment section, and don't forget to like and subscribe to my channel.